Ivory Coast is not only known as a country with a developed mining industry in West Africa, but also the world's largest cocoa producer, accounting for about 40 to 45% of global cocoa production. Thanks to abundant raw materials, this country has strongly developed the cocoa processing industry into semi-finished products and export chocolate. Today, we will explore the process of processing cocoa into chocolate in a modern factory. The cacao tree, or Theobroma cacao, food of the gods in Greek, grows perfectly in the tropical climate of Ivory Coast, with stable temperatures of 75 to 85 degrees Fahrenheit, abundant rainfall of 60 to 80 inches per year, high humidity of 80 to 90%, and nutrient-rich alluvial soil. Cacao trees grow under the tropical forest canopy with light shade from taller trees. This is sustainable agroforestry cacao, planted interspersed with fruit trees, protecting forests and biodiversity. The cacao tree has a long growth cycle. From seedling to fruiting takes 3 to 5 years. The miracle is that cacao pods do not grow on branches, but directly from the trunk and large branches, a phenomenon called cauliflory. Each mature tree can yield 20 to 50 pods per year. Cacao pods are oval-shaped, 6 to 12 inches long, weighing 1 to 2 pounds, with thick, hard shells, yellow, orange, or red, depending on the variety. Inside contains 30 to 50 cacao beans wrapped in sweet white pulp, mucilage. Average yield is only 0.8 to 1 ton of dry beans per hectare. That is why cacao is precious. Identifying ripe pods is a traditional skill. After 5 to 6 months from pollination, cacao pods ripen when the shell turns bright color, yellow to bright yellow, green to reddish orange. When tapping lightly on the pod, there is a dull thud-thud sound, a sign seeds inside have separated from the shell. The main harvest season is from April to June, and the secondary season from October to December. Cacao harvesting is completely manual, using long-handled machetes to cut pods from the trunk, extremely carefully not to damage the tree bark and surrounding small flower buds. Immediately after harvest, cacao pods are opened on the spot in the forest or at collection centers. Workers use machetes to chop strongly into the pod, separate the shell, take out cacao beans wrapped in white pulp by hand. Each skilled worker can open 500 to 700 pods per day. Fresh cacao beans are pale purple to white, with a sweet, sour taste from the surrounding pulp. Beans are collected into large crates or baskets. Cacao shells are not wasted. They are dried to make compost or animal feed. Practicing circular agriculture. The most important step: fermentation. Fresh cacao beans are placed in wooden boxes or piled up, covered with banana leaves, to ferment naturally for 5 to 7 days. During this process, temperature rises to 113 to 122 degrees Fahrenheit due to bacteria and yeast activity. Fermentation kills the germ inside the bean, develops characteristic chocolate flavor, and changes bean color from purple to brown. Farmers turn beans daily for even fermentation. This is the magic turning raw cacao beans into chocolate ingredients. After fermentation, cacao beans are sun-dried for 7 to 10 days on large drying yards or bamboo racks, turned evenly daily until moisture drops from 60% to 6 to 7%. Dry beans are dark brown, hard shell, noticeably lighter. Then, beans are packed in 60 to 70 kilogram bags, transported to the chocolate processing factory. The first step in the factory is cleaning and sorting. Cacao beans are poured onto a conveyor belt through a vibrating screen, removing stones, sticks, debris. Then, AI optical sorting machines remove damaged, moldy, or off-size beans. Only perfect, uniform beans 0.8 to 1.2 inch are put into production. Cacao bean roasting flavor transformation step. Clean cacao beans are put into giant roasters, rotating like clothes dryers. Roasting temperature 250 to 350 degrees Fahrenheit for 20 to 40 minutes, depending on bean type and desired flavor. Light roast 250 to 280 degrees Fahrenheit for fruity sour chocolate. Dark roast 320 to 350 degrees Fahrenheit for strong bitter chocolate. The Maillard process occurs a chemical reaction, creating over 600 complex chocolate flavor compounds. Roasted beans are darker brown, dry, brittle shell, chocolate aroma spreading throughout the factory. This is the soul of the chocolate bar. Winnowing and grinding technical stage. Hot roasted beans are cooled quickly, then fed into the winnowing machine. The machine crushes lightly cracking shells. Then a strong air suction system blows light shells out, keeping the nib, the inner kernel, containing 50 to 55% cocoa butter and cocoa solids. Cacao nibs are small, irregular pieces, dark brown. Cacao shells are collected for compost or animal feed, nothing wasted. Turning nibs into cocoa liquor, golden liquid. Cacao nibs are put into granite stone mills or modern metal grinders. Ground with pressure and friction, heat 100 to 120 degrees Fahrenheit. Since cocoa butter accounts for 50 to 55%. When ground, nibs melt into a dark brown thick liquid called cocoa liquor or cocoa mass. This is 100% pure cocoa, bitter and not sweet. Grinding process takes 8 to 24 hours, depending on desired fineness. Cocoa liquor is the basic ingredient for all chocolate products. Part is moved to make chocolate. The other part is pressed to separate butter. Separating cocoa butter, important stage. A portion of cocoa liquor is put into a hydraulic press with extremely high pressure, 4,000 to 6,000 psi. Golden cocoa butter flows out, leaving solid cocoa cake containing 10 to 20% butter. This cake is ground into cocoa powder used for drinks and cakes. Pure cocoa butter is pale yellow, light aroma, melting at 93 to 98 degrees Fahrenheit. This is the ingredient creating smooth melt and mouth texture for chocolate. Cocoa butter is one of the most expensive vegetable fats in the world. Ingredient blending secret formula. In giant stainless steel mixing tanks, cocoa liquor is blended with cocoa butter, 20 to 40% depending on chocolate type. Sugar, 30 to 50% for milk chocolate, 10 to 30% for dark chocolate. And milk powder, 20 to 30% for milk chocolate, 0% for dark chocolate. Dark chocolate, over 70% cocoa, low sugar. Milk chocolate, 30 to 40% cocoa, lots of milk sugar. Mixers blend the mixture evenly at 104 to 122 degrees Fahrenheit for 4 to 12 hours. Added soy lecithin, 0.5%, for emulsification, and natural vanilla, 0.1%, to enhance flavor. This is the exclusive formula of each brand. Refining, creating perfect smoothness. The mixture after blending is still coarse sugar, and cocoa particles have size 50 to 100 microns, larger than tongue perception threshold, 30 microns. The mixture is passed through a roller refiner with 5 stacked metal rollers. Gaps between rollers decreasing from 200 microns down to 15 to 20 microns. The mixture passes through many times until completely fine, checked by micron meter. The result is a chocolate mass smooth as velvet. No more gritty particles when eating. This is the secret of premium chocolate. Conching, smoothing, and flavor development. This is the exclusive step of premium chocolate. Refined chocolate is poured into the conche machine, a special mixer with strong friction rotating shafts. Temperature 130 to 180 degrees Fahrenheit, operating continuously 12 to 72 hours. Goal: 1. Evaporate moisture and excess acid. 2. Smooth further. 3. Coat cocoa butter evenly on particles. 4. Develop complex chocolate flavor. Milk chocolate conches 8 to 12 hours. Dark chocolate 24 to 72 hours. Result is melting smooth chocolate, no astringent bitterness, seductive aroma. Tempering chocolate for perfect crystallization. Chocolate after conching is cooled and heated according to a precise cycle. Dark chocolate, 113 degrees. Fahrenheit cooled to 81 to 82 degrees Fahrenheit, then reheated to 88 to 90 degrees Fahrenheit. Milk chocolate, 104 degrees Fahrenheit, cooled to 81 to 82 degrees Fahrenheit, then raised to 84 to 86 degrees Fahrenheit. This process helps cocoa butter crystallize in stable form, 5 creating gloss, snap when broken, even melt in mouth, and no blooming when stored. Tempering machines automatically control temperature precisely plus or minus 0.5 degrees Fahrenheit. Tempering check by dipping knife chocolate hardens in 3 to 5 minutes is standard. Molding, shaping chocolate bars. Tempered chocolate is pumped into automated molding machines. The machine pours chocolate into metal or heat-resistant plastic molds of various shapes, rectangular bars, round balls, heart shapes. The machine vibrates lightly 5 to 10 seconds to remove air bubbles, creating a smooth, flat surface. Then, molds pass through a cooling tunnel 41 to 50 degrees Fahrenheit for 15 to 20 minutes. Chocolate solidifies completely. Finally, the machine automatically flips molds. Chocolate pops out perfectly shiny, no dents or bloom. Quality inspection. Every bar is perfect. Chocolate bars automatically pass through inspection systems. AI cameras scan 100% surface checking gloss. Cracks, bubbles, deformation. Electronic scales check weight. Error plus or minus 0.5 grams. QC team randomly samples checking snap test, crispness when broken. Melting point must be 93 to 98 degrees Fahrenheit. And sensory, taste, smell, texture. Pass rate, 99%. Defective bars are returned to remelt, rework. No waste. Packaging protection and decoration. Standard chocolate bars are wrapped in foil automatically, then wrapped with an outer paper layer printed with beautiful Monchoco label with nutritional info. Expiration date, 12 to 24 months. And traceability, QR code. Packing machine, 200 to 300 bars per minute. Then, 20 to 24 bars are packed into cartons, taped, stacked on pallets. Each pallet holds 500 to 800 boxes, wrapped in shrink film and moved to cool storage 65 to 70 degrees Fahrenheit, waiting for distribution. From Ivory Coast, Monchoco chocolate begins the journey to the world. Refrigerated containers carry thousands of boxes from factory to Abidjan port, the largest port in West Africa. Giant container ships carry chocolate crossing the Atlantic 15 to 20 days to Rotterdam, Hamburg, New York ports, and many other places. Container cooling systems maintain 65 to 68 degrees Fahrenheit throughout the journey, so chocolate doesn't melt or bloom. From ports, chocolate is distributed to supermarkets, specialty stores across Europe, US, and Asia. And finally, the Mon Choco chocolate bar reaches global consumers. From the tiny cacao pod in the Ivory Coast rainforest through 12 strict processing stages with science and art roasting. Grinding, blending, conching, tempering, molding to the melting smooth chocolate bar in your hand. The journey takes a total of 4 to 6 months. Each chocolate bar is a harmony of the labor of 2 million Ivory Coast farmers and the world's most modern technology. When you enjoy chocolate, you are tasting the tropical African heart and human talent. Have you ever tried cooking sugarcane sugar at home, but the finished product is never as white and fine as store-bought sugar? The truth is, producing pure white sugar is much more complicated than you think. In the factory, they use modern equipment systems, continuously monitored by AI, along with closely linked production lines. Every stage is strictly controlled regarding time, temperature, and pressure, precise down to every detail. Just a small deviation in parameters at any stage, and the whole batch could be completely ruined. Everything happens continuously from the moment the sugarcane is brought into the factory until the finished product enters the packaging chain. And now, we will begin to explore each process in detail. In Florida, known as the Sugarcane Kingdom of America, over 400,000 acres of fertile land by Lake Okeechobee are dedicated to sugarcane. This organic soil, with a warm subtropical climate year-round and abundant rainy season, provides ideal conditions for cane growth. Each year, Florida produces about 19.72 million short tons, accounting for more than half of the country's output. As for Louisiana, the northernmost place in the world that can still grow sugarcane, farmers utilize the fertile alluvial soil of the Mississippi River Delta. With 497,800 cultivated acres, Louisiana produces about 15.21 million short tons of cane annually. Notably, Louisiana became the first state to surpass Florida in refined sugar production in 2023. Sugarcane is a grass family plant, grown not from seeds, but by using the cane stalk itself as seed. In the fall, from July to August, farmers cut sections of the stalk containing buds and place them into prepared furrows. This is a unique vegetative propagation process, helping new plants sprout from the nodes of the old stalk. After planting, the cane needs 12 to 18 months to fully develop before the first harvest. During this time, the cane can grow 7 to 9 feet tall with sturdy stalks full of sweet juice. The miracle is that after cutting, the remaining stubble will automatically grow into a new plant called a ratoon and can be harvested 3 to 4 more times from the same planting. Modern American farmers use GPS technology with sub-inch accuracy to control tractors, ensuring precise fertilization and irrigation. U.S. Sugar in Florida even owns one of the world's largest private Wi-Fi networks, spanning 270 square miles, helping to monitor and manage the entire farm remotely. Sugarcane needs about 0.53 to 0.79 gallons of water annually to grow well. In Louisiana, natural rainfall is usually sufficient, but in Florida, many farms use modern sprinkler systems. Fertilizer is added regularly from planting until maturity, providing necessary nitrogen, phosphate, and potassium for growth. The ideal temperature for sugarcane growth is about 20 degrees Celsius, 68 degrees, or higher. Interestingly, cooler weather at the end of the growing season actually helps the cane accumulate more sugar. That is why the main harvest season in Florida is from October to May, while in Louisiana it is from September to January when the weather turns cold and sugar content peaks. During growth, farmers face many challenges such as pests, weeds, and harsh weather. The sugarcane borer is the #1 enemy, capable of reducing yield by 10 to 20% if uncontrolled. Fortunately, experts at the LSU Ag Center and University of Florida continuously research new cane varieties with better resistance. When the cane reaches perfect ripeness after 12 to 18 months, the harvest season begins as a race against time. Why? Because immediately after cutting, the cane starts losing sugar due to natural decomposition. Therefore, the cane must be delivered to the factory within 24 to 48 hours. In Florida, the entire 400,000 acres of cane require 6 to 7 months of continuous harvesting and processing. Most American farms today use modern combine harvesters, giant machines that can harvest and process cane automatically. These machines can cut 7.72 to 9.92 short tons of cane per hour. Rotating knives at the front cut the stalk at the base, then overhead blades top the plant. The stalks are chopped into short pieces called billets and blown into wagons running alongside. However, on some smaller farms or hard-to-reach lands, manual harvesting is still practiced. Workers use long machetes to cut each stalk near the base, remove leaves and tops, then stack them into bundles. This is extremely strenuous work under the sun. An experienced worker can cut about 1.10 short tons of cane per day. How impressive is U.S. sugarcane yield? On average, each acre yields 33 to 38 short tons of fresh cane. In 2023, Louisiana reached a record with over 2.20 million short tons of raw sugar produced. All harvested cane is transported immediately by truck, train, or even barge to the nearest processing mills. As soon as the cane arrives at the factory, it is weighed and washed to remove soil, rocks, and debris. There are currently 11 mills in Louisiana and 4 in Florida. The cane then goes through rotating knives and shredders, turning it into small pieces to easily extract the juice. This mechanism is like squeezing an orange for juice, but on a huge industrial scale. The next step is milling, the most critical stage. The shredded cane passes through 4 to 6 pairs of giant rollers rotating in opposite directions, pressing hard to extract the juice. To increase efficiency, hot water at 70 degrees, 158 degrees, is sprayed countercurrent to the cane, helping dissolve more sugar from the fiber. The result? Juice with about 17% sweetness is collected, while the remaining fiber, called bagasse, is reused as fuel for the factory. Fresh cane juice contains many impurities like wax, fats, proteins, and dust particles. To clean it, it is heated to 105 degrees, 108 degrees, and mixed with lime, calcium hydroxide, and flocculants. Lime helps neutralize acidity, preventing sugar from breaking down into glucose and fructose. The mixture is then put into large clarifiers, where heavy impurities settle to the bottom and clear juice is drawn off from the top. The clear juice is pumped through a multiple effect evaporator system, an energy-saving technology invented in 1843. This system has 3 to 5 evaporators connected in series. Steam from the first vessel is used to heat the second. Steam from the second heats the third, and so on. Thanks to this, juice with 10–15% sugar is concentrated into syrup with 55–60% sugar. Now comes the crystallization stage, where the magic happens. The thick syrup is fed into vacuum pans, giant tanks with low pressure that allow the syrup to boil at a lower temperature, avoiding burning the sugar. When the syrup reaches saturation, tiny seed sugar grains are added. Sugar molecules in the syrup attach to these seeds and grow, forming sugar crystals. The crystallization process happens 3 times. The first, A strike, yields the highest quality sugar and A molasses. This molasses is boiled again to create B strike and B molasses. Finally, C strike creates the final sugar and blackstrap molasses, a thick, dark molasses containing about 25% sugar, too low to crystallize further, so it is sold as cattle feed or industrial feedstock. The mixture of sugar crystals and molasses, called massacute, is poured into a centrifuge, a device spinning at extremely high speeds like a clothes spinner. Centrifugal force pushes the heavier molasses out through a screen, while the lighter sugar crystals are retained inside. Raw sugar, yellow-brown, with 97 hot 99% purity, is collected and dried to 0.5% moisture. Raw sugar is cooled on long conveyor belts and stored in large warehouses. It can be sold directly or transported to distant refineries by train, truck, or ship. And this is only half the journey. To get pure white sugar, we need one more step: refining. At the refinery, raw sugar undergoes affination washing, mixed with warm, concentrated sugar syrup to dissolve the molasses layer, coating the crystals without dissolving the crystals themselves. This mixture is called magma, with a Brix of about 92. The magma is then heated to 4360 degree high, 109.4, 140 degree, and put into a centrifuge to separate the sugar crystals from the affination syrup. The crystals after affination are completely dissolved in hot water at 65 degree, 149 degree, creating a liquor with 65% dissolved solids. Now, this liquor needs to be thoroughly cleaned. There are 2 main methods: carbonatation, injecting CO2 gas through the solution to create calcium carbonate precipitate that absorbs color impurities, or phosphatation, using phosphoric acid and lime to create calcium phosphate precipitate. Both remove proteins, wax, and colorants. After chemical cleaning, the sugar solution is filtered through multiple layers of cloth or high-pressure membranes to completely remove precipitate particles and remaining impurities. The crystal clear liquor now has a very pale yellow color, but is not yet white enough for premium products. That is why we need the next step: decolorization. Decolorization is performed using activated carbon, or ion exchange resin. Activated carbon with millions of microscopic pores absorbs remaining brown color molecules. The liquor is pumped through columns containing activated carbon, and when it exits, it is almost transparent and colorless. The carbon, once saturated, is regenerated with hot steam and reused multiple times. Now, this pure liquor is fed into an evaporation and crystallization system for the second time, just like at the cane mill, but with much higher purity. The liquor is concentrated in a vacuum to 68% solids, then put into vacuum pans for crystallization. This time, pure white sugar crystals of 99.9% are formed, almost pure sucrose. White massicute is centrifuged like raw sugar, but this time, brilliant white sugar crystals are born. These crystals are still wet, so they are sent into a rotary dryer, a large rotating drum with hot air at 85, 95 degree, 185, 203 degrees, blowing through. Moisture content drops to just 0.02 or 0.05%, ensuring the sugar does not clump and can be stored for a long time. Some sugars have special particle sizes like powdered sugar, baker's sugar, superfine, or coarse sugar. After drying, the sugar is graded by size using vibrating screens. Powdered sugar is ground fine and mixed with 3% cornstarch to prevent clumping. Coarse sugar is crystallized at lower temperatures to create larger grains. Before packaging, every batch of sugar must undergo strict quality inspection. Technicians analyze purity, must reach a minimum of 99.7% sucrose. Color, using the Icumsa scale, the lower the number the whiter. Refined white sugar is usually under 45 Icumsa. Moisture and microbiological checks. Samples from each batch are kept for traceability if needed. Modern automatic packaging systems can handle 50 to 100 bags of sugar per minute. Sugar from storage silos is fed into automatic weighing and packaging machines. The machine measures every gram precisely, pours sugar into paper or plastic bags, seals the top, applies a label with a QR code for traceability, and stacks them on pallets. AGV robots automatically transport pallets to the finished goods warehouse. Packaged sugar is stored in temperature and humidity-controlled warehouses, then distributed to supermarkets, food factories, restaurants, and households across the U.S. and the world. Famous brands like Domino, C&H, and Florida Crystals all produce according to this process. From a green sugarcane stalk, we have obtained a pure white grain of sugar, a magical journey, isn't it? The U.S. sugarcane industry not only creates millions of tons of sugar annually, but also contributes over $20 billion USD to the economy and creates jobs for over 150,000 people. Notably, the industry is becoming increasingly sustainable. Bagasse is used as renewable fuel. Filter mud becomes fertilizer, and some mills like Florida Crystals achieve carbon neutral certification, generating enough electricity from biomass. However, sugar still needs to be consumed responsibly. The WHO recommends adults should not eat more than 0.88 to 1.76 ounces of free sugar per day, about 6 to 12 teaspoons. Sugar provides quick energy, but excess can cause obesity and diabetes. So enjoy sugar smartly so it sweetens life without harming health.